In this video, we will learn about a very interesting class called Arrays. And also I will explain about Comparator. So the class name I have given is Comparator Demo. So first we will have demonstration of Arrays, then we will look at Comparator. Arrays is a class which is present inside util package and it is having lots of useful methods. Let us look at those methods. See, for explaining about arrays class, I have taken two arrays A and B, integer type arrays, and the elements are same. If you check them, the elements are same, 2, 4, 6, 8, 1, 3, 5, 7. The elements in both of them are same. Let us check arrays. It is having static methods, right? Arrays dot, I can access the methods. Binary search, so there is a method for searching. So I can search a particular element in an array. Okay, I'll come to it afterwards. Compare method is there. Comparing to integer type array or generic array, boolean, byte, char, double, float, int, long, short, and okay. Compare with the starting and ending index also. You can compare two arrays with starting and ending index. But what actually this compare do? Let us check it. So I have integer arrays. I will select this one and I will give A and B. So automatically it has taken A and B. So what I will do is I will print its result. Compare array A and array B. Let us run. I got the output as 0. It means both the arrays are same. They are equal. Though these two are two different array objects, but they are equal. Okay. I will remove one number from here. Then let us check what happens. First array is having one element extra, so it is greater than the second array, right? It is greater than second array. So that's why result is 1. Now let us do one thing. Remove one element from the first array. Then check. -1, because first array is having one element less than, second array is greater than first array because all the elements are same, just one element extra second array is having. Now I will show you one more thing. So how it is comparing? Is it comparing length? No, it is comparing elements also. So at last I will give the element as 2. See, the first array is having almost same elements as in array B, but only the last element is different. So first array is having smaller element. So we can say first array is smaller than second array. Yes, so -1 we should get. Yes, got -1. Now let us change one more value. This is 7 only. First element itself I will change. First element of array B I will make it as 1. So it will compare element by element. So first element of array B itself is smaller than array A, so A is greater, so we should get the answer as 1. Yes, we got the answer as 1. So that's it. Through examples, I have explained you that compare method will compare the corresponding elements of an array. If at any one point there is a mismatch, then it will check which is greater. If first one is greater, first A is greater, then it will return 1. If B is greater, it will return -1. If both are same, there is no mismatch, then it will return 0. This is comparing two arrays. And I am comparing both the arrays with all the elements. You can also compare the element with starting and ending index also. Now let us check other methods. I will remove this. Then dot. Binary search is there, compare is there, compare unsigned is there. Copy. It will give a copy. Copy of. So you can give a array like here. If you check this one, integer array is given, and also you can give the length if you want, and you will get a new copy. So let us take a copy of this array A. Okay, let us call this one. So I will call this method arrays dot copy of. Okay, copy of, I want integer type, so A, and I want total 4 elements. Okay, so this will return an array. I should take it in an array, so I will create one more array reference, that is C. Then using this for loop, that is for each loop, I will print all these elements. I will print all these elements. That is from C. Okay, let us remove this and just write X here. Now read the code once. Array A is there, array B is there, and I am making a copy of A for 4 elements, only 4 elements, that is 2, 4, 6, 8, and that should create a new array C, and I am printing all the elements of array C using for each loop. X will take the elements and X I am printing. Let us run. Yes, 2, 4, 6, 8. So you can copy the elements. If I want to copy all the elements, then I should say A dot length. So it will copy all the elements. Yes, 2, 4, 6, 8, 1, 3, 5, 7. All the elements I got. Then I will show one more method. Arrays dot. Okay. So copy is over. Equals is there. And deep equals. This is useful upon an object. If two arrays are array of objects, then you can compare the objects also. So deep equal will work upon comparing the objects. Equals is there, comparing. So it is same as compare. So equals will return true only if they are equal. So you can compare the entire array as well as you can give starting and ending index of a array also. Fill is there. I will call this method fill. This I will take array C and I will give the values as 10. So the entire array C will be filled with the values 10, and when I am printing array C, all the values 10, 10, 10 will be displayed. See, already I am creating a new array C by taking a copy from A. Then after taking the copy, I am filling that array C with 10. So this is just like initializing an array. So if you have to initialize an array at any time with the same values, then you can use the method fill of this arrays class. Like sometime we have to initialize the entire array with 0 or entire array with -1. Then you can use this method fill. Right? Let us run. I should get 10, 10, 10. Yes, all values are 10. That's it. Now let us look at more methods. So we have seen fill. So after fill, what are the methods available? Hash code method is there. Then mismatch method is there. So it will find out whatever is there is a mismatch, at which index the elements are mismatched. So you can know till where the elements are same and from where they are mismatching. Alright. So parallel sort. So actually this is sort, but it is parallel sort is nothing but a merge sort which uses multi-threading for sorting the elements. So parallelly it will sort the list. So you can use sort. Just I am showing this sort. So whether you use parallel sort or this sort, that's a matter of choice. If an array is small, then you can go for this sort. If an array is large, then go for parallel sort. So let us call this method sort. Sort C. See, I have removed filled. I got all the elements of A into C, then I am sorting, then I am printing. So these elements must be sorted. 1, 2, 3, 4, 5, all these must be sorted. Yes, 1, 2, 3, 4, 5, 6, 7, 8, sorted. So this is sorting the numbers, integers. So it knows very well which integer is smaller, which integer is greater, because integer is primitive type, right? So sorting requires comparison of elements. So yes, comparison of elements can be done because these are integer type. If these are not integers, these are user-defined class objects. Our class objects, then we must define how to compare the objects. So for sorting, comparison is very important. Again, I am stressing on the point, for sorting, comparison is very important. So we will talk about comparison afterwards. One more method I will show you. I will remove this for each loop. Then upon the C, when it is sorted, I can perform binary search. See, binary search can be performed only upon sorted array. So sorted array integer. See, the array C is sorted. So I will give array C. Then I want the index of element 2. So if you check after sorting, 1 will be at index 0, 2 will be at index 1. So I should get the answer as 1 in a sorted array. Yes, I am getting it as 1. So just now you have seen that C was sorted, right? We have done it. So I have also displayed it. So in that 2 is at index 1. So binary search can be performed if it is sorted. So make sure it is sorted, then you perform binary search. So that's all about the methods, important methods I have shown you. If you want to explore the class and try all methods, you can do it. Now let us do one more thing. Instead of taking integer primitive type, let us take wrapper class integer. So wrapper class integer. Then instead of sorting this, taking in C, okay, I will sort A itself. I will sort. Will it sort this or not? Yes, it will sort. So let us print all the elements after sorting. I will remove this. Okay. Using a for each loop, I will print all these elements. So for integer x from array A. See, I will remove this B, no need of B now. Only for comparison that was useful. Now look at the code once. I have an array of integer objects and these are integers. We can initialize them like this. So these are not integer primitives now. They will become objects of type integer. And sort will sort those objects. When I print, I should get the elements in sorted order. Yes, it is able to sort the integers also. See, I said that for sorting, comparison is very important. So for comparison, if you want define, you can define your own comparator. So if you're writing your own class, then you must define your own comparator. Now let us look at comparator interface. For implementing comparator interface, see, we have seen comparable interface, but comparator interface, you have to write a separate class for comparator interface. So I will write class like my implements comparator, and this is a comparator for integer. See, when we use comparable for our own class, like suppose our point class is there, so we can implement comparable. For the same point class, if you want to implement comparator, you can write it as a separate class. So inside this, you have to write down this compare method, compare, which will take two integers I1 and integer I2. Now what I am going to do is, we know that 1 is smaller than 2. So if I1 is less than I2, then the comparison value will be -1. When comparison is done, we get -1. But we will return 1. So we are reversing. And if I1 value is greater than I2, so it should be return 1, but actually we will return -1. So it will be reversing the order, right? Yes, it will be reversing the order. So I have implemented compare method inside comparator interface, right? By reversing the order. If it is a small, first one is a small, we should get -1. Compare we have seen, right? So it will return -1, but we will return 1. So it means if the number is smaller, actually it is greater. So it means it is reverse order. So let us now sort using comparator. So I will show you the method. Arrays.sort. See, sort is there for all primitive types, and for generic, for any type, you can also pass comparator. I will pass comparator. So what is the name of a comparator class? My. So I will give my, object of my is given. That's it. So it is comparing and giving reverse results. So it should get sorted in reverse order. Let us check. Yes, 8, 7, 6, 5, 4, 3, 2, 1. So it is comparing them in reverse order. So that's it. I have shown you what is comparator also. So comparable we have seen in the previous video. Now we saw comparator. For the point class, we have written comparable. So for the same point class, you also define comparator also. Write it as a separate class. And it is useful with this sort class. Okay, because it requires comparator, it doesn't require comparable. If you sort it without giving anything, then the comparable interface will be used. That comparably will be used. And if you want to pass comparator, then you can pass it separately. So that's all in this video. Practice all these things, whatever I have shown you. And this class is very useful, arrays class. So for various simple operations, it is very useful. That's all in this video.